All right, so today we are going to review rational functions. Again, this is a topic you learned back in Algebra 2, but we're just going to be looking at it again, review some of the key vocabulary and key characteristics of rational functions. So first off, what is a rational function? A rational function is a function, so I'm going to call it f of x, that does have a numerator and a denominator, and both the numerator and the denominators are going to be polynomials. Just because you see a function that has like a fraction does not make it a rational function. To be a clear rational function, again, both the numerator and the denominator have to be polynomials, which means you have coefficients and you have x's raised to a power. And of course, those coefficients could just be, especially for the numerator, could just be a number like 1 or 2. So some of the vocabulary that I want to review and some of the skills I want to review, I'm going to start off with these. And so the first thing I want to talk about is simplifying expressions. We need to be able to simplify these expressions. It can help us graph them, it can help us analyze them, and next week we'll look at solving them as well. So whenever you simplify expressions, mainly we're going to factor and cancel. And of course, we're never going to cancel across plus or minus signs. We're only going to cancel factors out. An excluded value, we know in math that we cannot divide by 0. So an excluded value is whenever the denominator is equal to 0. And the reason again why is because we can't divide by 0. And so characteristics. We looked at characteristics already as a review. We know the y-intercept. To find that easily, you're going to plug in 0 for x. For the x-intercepts, you're going to set equal to 0 and solve. If you have an expression that's just a fraction, like there's nothing added or subtracted on the outside of that, oftentimes we're just going to set the numerator equal to 0. So that is the first part I want to review. Next that we're going to review is our asymptotes and then also our wholes. So a lot of these do come from excluded values. I'm going to talk about the horizontal asymptote first. The horizontal asymptote is basically what the graph is settling on. Now when it comes to these functions, they either are going to have one horizontal asymptote or no horizontal asymptote. It won't have really more than one if it's a true rational expression. And your horizontal asymptote can either be in the form of y is equal to 0, basically meaning that your asymptote is the x-axis. It could be y is equal to a number, or there could just be none. Your horizontal asymptote is going to be equal to 0, and we're going to talk about the degrees of the function, but basically when the degree of the numerator is smaller than the degree of the denominator. Basically, if it is bottom heavy, then it's going to be y is equal to 0. It's going to be y is equal to a number when the degree of the numerator is equal to the degree of the denominator, and that number is going to be given by a ratio of the leading coefficients. And we'll look at an example like that last. And then the horizontal asymptote is when the degree of the numerator is bigger than the degree of the denominator. Next type of horizontal asymptote is going to be a slant asymptote. The slant asymptote is going to be a possible case when you have no horizontal asymptote. And we're going to have a slant asymptote when the degree of is bigger by 1. And when I say slant asymptote, we're talking about like literally an asymptote that is slanted diagonal. We can also have slant asymptotes as like an asymptote that's like a quadratic shaped, an asymptote that's a cubic shaped. It could really be any type of polynomial. The only one we're going to be concerned about is the slant asymptotes when the numerator degree is one bigger than the other. To find it, we are going to do everyone's favorite of some long division. And then we have our vertical and asymptotes and our holes. Both vertical asymptotes and holes are going to be excluded values. And so that means they both come from when the denominator is equal to 0. The difference between a vertical asymptote and a hole, in that a hole is going to be a factor that cancels out, and the vertical asymptote is going to be one that is, I think of as being left over in the denominator. So we're going to look at some examples next in the next video. I have 3 examples for us to look at of various types of problems.